In this video, we are going to learn how to solve exponential equations. Now, the main strategy is when we have base with exponent on the left side and another base with exponent on the right side, when the two base is same, the exponent must be same. Let's just pick an example. 2 to the power of 3 or 2 to the raise 2 has been raised to 3. So it's the same value. But 2 to the exponent of 3 on the right hand side, we can simplify it as 8. So 2 to the power of 3 actually is an 8. Now we just set a value. Let's say instead of 3, we can plug in x. So we are setting a value x equals to 3. Now, when the base is 2, the other base is 2. On this side, instead of 3, we plug in x. The other side, we keep the 3. And to simplify the right side, we just come out with the value is 8. Now, we will take this part and take that part, and we will make a problem with that. So let's make a problem taking the value 2 raised to x on the left side, and the simplified value on the right side is 8, and we will solve it. We know the answer in the top. So what the strategy is, we try to keep the same base on the left and the right. The left side base is small, so no choice, it has to be 2. The right side is 8. We try to keep a base 2, and we decide the exponent 2 to the exponent of what should be equals to 8. So the answer is 2 to the exponent of 3 equals 8. Since these two base is same, x must equal 3 because 8 is exponentially related to 2. So the final answer, x is 3. This is how we solve exponential equations. Now we have another problem, 2 raised to x equals 16. So the strategy is we keep the base on the left, on the right same. The smallest side base is 2. So we just write 2 on the left side with the x. But on the right hand side, we need another base, but we have to decide the exponent. And the question is 2 to the exponent of what equals 16? And the answer is 4. 2 times 2 times 2, 4 times equals 16 because 16 is exponentially related to 2. And obviously, since the two bases same, x equals 4. Another example, 2 raised to x. And the final answer is 64. So basically 2 to the exponent of what is 64? That exponent is going to be the answer or the value for x. So the strategy is same base on the left, which is 2. Base on the right, we match this 2. But decide 2 to the exponent of what is 64. You can use a calculator. 2 to the power 4, 5, 6 is 2 to the power 6. It should be equal to 64 because 64 is exponentially related to 2 to the power of 6. So the final answer, x equals 6. In this video, we have a exponential equations, but this time the exponential is a group of values. So it's 2 to the exponent of x plus 1. That's the group. The whole value is the exponent equals 16. Strategy is same base on the left side, same base on the right side. So the left side base is 2, which is the smallest one. Exponent is x plus 1 on the left side. The deciding factor is 2 to the exponent of what equals 16, and the answer is 4. So since the two base on the left side and right side is same, the exponential value of the left side x plus 1 must equals to 4. They must be same. So x plus 1 equals 4, and we just solve for x. Either we subtract 1 from left side or we move the 1 on the right side, is the same thing. X is equals 4 minus 1, which is x equals 3. 3 is the right answer. Another example on the right hand side, if we have 2 to the exponent of x minus 5 equals 16, same strategy. Make two base same, left side and right side. The left side base is already 2. The right side, we have to write a 2 to match the left side. We copy the exponent on the left side. On the right side, same question, 2 to the exponent of what is 16? The answer is 4. So the exponent value on the left must equals to the exponent value on the right, since the two bases is same. So it should be x minus 5 equals 4. We add 5 on both sides, or we move the 5 on the other side and make it positive. It's the same thing. So x equals 4 plus a 5, and the final answer is x equals 9. And we are done. In this video, we have example includes fraction. Left side 2 raised to x, right side 1/16, but still 16 is exponentially related to 2. So the strategy is same. The left side, the base is 2 with the exponent x. On the right hand side, we try to change the 16 as a base of 2. So 2 to the power of 4 is 16. But the left side base and the right side base is still not same. So what we do is we use the negative exponent laws. 1 over 2 to the power of positive 4 is 2 to the exponent of a negative 4. Now the base on the left and the right is same. X must equals to negative 4. Similar example, if we have an exponential value on the left side with a decimal value, all we do is 10 base. We keep the base 10 for now. The decimal number, we convert it to a fraction. 1 over 100 is the same value as 0.01. Now we match the 100 as a power of 10. 10 to the exponent of 2 is 100. So 10 to the power of x equals 1 over 10 to the power of 2. And by negative exponent law, 1 over 10 to the power of positive 2 is 10 to the exponent of a negative 2. Now we have made the base on the left and the right same. So obviously the exponent of the left and the exponent of the right must equals to same. So x equals negative 2. And we are done. This example, we have 3 raised to x equals 1. Strategy is same. We must match the base of the exponent. We must match the base on the left and right side same. Left side is base is 3, exponent is x. Now the right side, we have to select a base of 3. There is no other choice. And as there is exponential law, any value with the exponent of 0 belongs to 1. But this occasion, the value has to be chosen as a 3 because we have a base 3 on the left side. And 3 to the 0 is 1. Now the base is same, so obviously x must equals to 0. One more example on the right side. If we have a value, doesn't matter how big it is, 397 raised to x equals 1. Same thing. Base is same, so we copy the base on the left side, keep the same exponent. But on the right side, we have to choose a base. Whatever base we choose, when we put the exponent 0, whatever the base is, the answer is 1. But we choose the same base at 397. 397 raised to 0 equals 1. Base is same, so x must equals to 0. And we are done. In this video, we have example 4 raised to exponent 2x, and 2 has been raised to exponent 5 minus x. So our main goal is 4 is the bigger base, 2 is the smaller base. We need to make the base on the left side same as the base on the right side. That's the strategy. So this 4, we can write the 4 as 2 to the power of 2, and the right side we just copy and paste as it is. Now the left side, we have a 2 base, but it has another exponent inside the parentheses. When we take it out, take the parentheses out, it's going to be the inside multiplied by the outside exponent. So it's going to be 2 to the power of 2 times 2x, 4x. And the right side, we just copy and paste the value. We have finalized and we have made the base on the left and the right same. So the value of the exponent on the left must equals to the value of the exponent on the right. So that makes 4x equals 5 minus x. And we just solve for x. We add x on the right side to get rid of the x on the right side, or we move the x to the left side. That becomes, the negative x becomes a positive x. And the right side value is 5. 4x plus 1x, which is 5x, equals 5. We divide both sides by 5. So dividing the left side by 5 is just the x, and the right side is just 1. And that's the final answer. We can do another similar example on the right side. 9 raised to x plus x. And 27 is raised to 2x minus 3. Now 9 and 27 is not exponentially related. But we have to know 9 is exponentially related to 3 and 27 is exponentially related to 3 as well. So what we do is change the 9 and change the 27 as 3 base. So 3 to the power of what is 9? 3 to the power of 2 is 9. And 3 to the power of what is 27? 3 to the power of 3 is 27. Now our base is same, but they have got internal exponents. We take the parentheses out. It's going to be the 2 inside multiplied by the outside exponent x plus 1. So the base is same. It's going to be 2 times this value. And it's going to be 3 times the value on the other side, which is 2x minus 3. Since the base on the left and the base on the right is same at the moment, the value of the yellow exponent on the left, the value of the yellow exponent on the right, they must equals to same. So it's going to be 2 times x plus 1 equals 3 times 2x minus 3. All we do is use distribution. 2 times x is 2x, 2 times 1 is 2. On the right side, 3 times 2x is 6, and 3 times negative 3 is 9. We have to isolate for x. 6x moves to the left side. Positive 6x becomes negative. It's the same thing as subtract 6x from both sides. Equals, we keep the negative 9 on the right. The positive 2 moves to the right hand side, becomes a negative 2. Left side is positive 2, negative 6 is a negative 4 with the x. And the right side is negative 2, negative 11. So negative 2 and negative 9 is a negative 11. Now what we have to do is, to get rid of the minus, we have to multiply both sides by negative. That makes that positive, that makes that positive. And finally, the right hand side, we divide this side by 4. X will be isolated, and we divide 11 by 4. So x equals 11 over 4. That's the final answer. And we are done. We have a little bit harder example. Left side 8, exponent is x minus 1. And on the right side, we have a radical is third power of root of 16. Now the strategy is, first is we keep the exponent on the left side as same, and the third side, third power of root, we keep it. Our main goal is play with the base of 8, play with the base of 16. 16 and 8 is not directly related exponentially, but 8 is related to exponential 2 to the exponent of 3, and 16 is related 2 to the exponent of 4. They're the same value. Now we have a base same. Now we have to isolate the 2 on the left, isolate the 2 on the right. To isolate the 2 on the left, all we have to do is take the parentheses out. It's going to be 2 to the exponent of 3 times x and 3 times the negative 1. So it's going to be 2 to the exponent of 3x minus 3. And on the right side, the root option, we have to make it exponential power. So it's going to be the same base. The outside exponent is the denominator, and the inside exponent is the numerator. This is how it changes. 2 to the exponent of 4 over 3. We have made the base on the left and the right same. So the value on the exponent on the left must equals to the value on the exponent on the right. We just solve for x. Now we have to make it fractionless. So we have a denominator of 3 on the right side. We multiply that side by 3, but we have to do the same thing on the left side. This 3 is cancelled by doing so. The left side is going to be 3 times the 3x, 3 times the negative 3, which is 3 times 3x is 9, 3 times negative 3 is negative 9, and the right side is simply 4. Adding 9 on both sides or move the 9 to the other side is the same thing. So we isolate 9x, move the 9 to the other side, positive 9, with the positive 4, the right hand side is 13. Now to isolate the x, all we do is divide the left by 9 and divide the right hand side by 9. So x is equals 13 over 9. That's the final answer, and we are done. Now we have a harder example on this problem. I've color coded it because we have to simplify or pay attention on the white value first. The green value will be taken care of later. When we have 6 to the power of x plus 1, if we just remember the basic, if we have 2 to the power of 3 times 2 to the power of 4, just putting an example, we are not adding the two exponents. If we just add and show the addition by not adding it. 2 to the power of 3 plus 4 is same as 2 to the power of 3 times 2 to the power of 4. So we use this strategy to simplify. 6 to the power of x plus 1 is the same thing as we are just going one step behind. It came from a multiplication of 6 to the exponent of x times 6 to the exponent of 1. The base was same and it's supposed to be added, and it was added. And copy and paste the green value, that's why it was color coded. Same thing, 3 to the exponent of x plus 4, one step behind. It came from expression like 3 to the x times 3 to the 4. These two exponents was added to write it as 3 to the exponent of x plus 4. And the green value we just copy. Now, next thing what we do is we factor out 6 to the exponent of x from the left side. We have 6 to the exponent of x times 6(1) and 6 to the exponent of x on the other side. What we do is just divide it by 6 to the x and divide that by 6 to the x. That makes this 2 is 1, this value is just a 6, minus 6 to the x divided by 6 to the x is just simply a 1. We do the same thing on the right side. Factor out 3 to the x. So dividing the white value by 3 to the x, this value is gone. We are just left with 3 to the power of 4 from this value. Subtract. If we divide this by this, is the same thing, same value. And dividing something same by same, the answer is 1. Now we have to find the value of 3 to the power of 4. 3 to the power of 4 is 3 times 3 times 3, 4 times, which is 81. With subtracting 1, the whole value of this parenthesis is just going to be 80. Showing this process is going to be messy. So left side is 6 minus 1 is 5. 6x times the 5 equals 3x times the whole value simplifies to 80. Now we have to get rid of the x on the right side because x has to be isolated. Though x is exponential, but it has to be isolated. So what we do is multiply left and right side by this reciprocal value of 3 to the x. This 3x is cancelled by this 3x. Now this 2 value, since it's 3 1/3 times the 6x, is going to be 6x over 3x times the 5 on the left side. It's just using algebra. We're just combining these two values on the left, times it by 5. And on the right side is just only one value, which is just 80. The reason I kept the space is 5 over 1 is same as 5, 80 over 1 is same as 80. But now we have to get rid of this 5. To do that, we have to divide this side by 5 and do the same thing on the right side. Dividing this side by 5 is absolutely gone. The left side is going to be 6x over 3 to the exponent of x, and the right side is going to be 16. Since these two exponent is same, 80 divided by 5 is 16. Since these two exponent is same, we can keep the fraction as 6 over 3 by the same exponent. If I simplify it, it's going to go back to 6 raised to x divided by 3 raised to x. Now the left side simplifies as 6 over 3 is 2 to the exponent of x equals 16. And we have done similar things before. And the right side is 2 to the power of 4 is 16. Since finally the base on the left and the base on the right, they're same, x must equals to 4. And we are done.